In this section, we start discussing lights and lighting in Vray. In the Create panel and Lighting tab, if you select Vray, you can see all the different lights that Vray has to offer. In the first few lessons, we're only going to discuss the main light type, which is Vray light. If I click on the Vray light, you can see that it includes different area lights like plane, disk, sphere, mesh, and dome. In this lesson, we are going to talk about plane, disk, and sphere types. Plane light is your normal square or rectangular area light. This is the light that you're probably going to use it 80% of times. Now, before creating our first light, let me quickly walk you through the scene. First of all, I have this clock and this very simple plane object that's going to work as our floor, and obviously a 3ds Max physical camera. Also, if I open up my render setting and go to the GI or Global Illumination tab, you can see it is enabled. Now, you don't need to know what GI is right now and what these parameters are doing here. You only need to know that GI makes our lights work more realistically, and having it enabled makes our light rays to bounce around basically. So let's create our first light. You can go to your commands panel and create it from there, or simply use Vray toolbar. In the toolbar, click on the Vray plane light and start clicking and dragging the light, in this case in the left view. In the top view, I'm going to move the light a bit to the left side. Also, let's change our left view to perspective view. One of the things you can do to make the positioning of your light easier is to enable the targeted option in your Vray light. If you go to the modify panel, and if it's not enabled, you can enable it. Now select the target and try to position it as close to your main subject as you can. Now select the light and position it as you wish. The exact position that I want for my light is -81, -100, and 36 on X, Y, and Z respectively. Let me go to my render settings and change the target to active shade mode and make sure that Vray RT is our render. Now I want you to go to Vray RT tab and enable undersampling. When undersampling is enabled, Vray RT starts the rendering at a lower resolution in order to speed up the initial preview, and now you can click on the render button. Okay, this is our initial render. To speed up the process, we can override all the materials in the scene. Let me stop my active shade. In the render setting window, enable override material, click on this none button and select Vray MTL and click OK. Now all the materials in the scene are going to be rendered with this simple gray material. Let's copy this material, change the target to production rendering mode. In the Vray tab, down to the global switches rollout, enable the override material here and paste instance the same gray material. Now let's get back to the active shade mode and click on render. Select your light and go to the modify panel and see what we have here. First, you can turn your light on and off, and you can see the result in real time in the Vray RT. Then we have type drop down, and as you can see, we have plane, dome, sphere, mesh, and disk type. We'll be talking about all of these area light types and shapes in this section, but for now let's focus on the parameters of the plane light. First, we have targeted, which creates a separate target for the light and allows you to point and direct the light source a bit easier. A few moments ago, we actually used this function to position our light around our subject. Then we have half length and half width, which control the size of our light. So let's set these to 40 and 40, and as you can see, suddenly the scene is a lot brighter and the shadows are a lot diffuser. Now let's set the half length to 8 and width to 13. And as you can see, now we have a darker scene and sharper shadows. I'll be getting back to this important topic of how the size of the light relates to its brightness and shadow sharpness in a moment, but to fully grasp the concept, I need to discuss different units that you can control your light intensity or brightness with. First, we have default units, which is very generic. In this unit, the intensity of the light depends or relates to the size of the light. So if I double the size of my light, you can see we get a brighter scene. Next, we have lumens, which in this unit, the emitted visible light will be measured in lumens. In this unit, the size and intensity of the light aren't related to each other. So if I increase or decrease the size of the light, as you can see, we have the same intensity. And the only thing that is actually changing right now, whether the shadows are getting diffuser as we increase the size of the lights or getting sharper as we decrease the size of the light. Now, next we have lumens per square meter per stadian. And in this unit, size and intensity of the light relate to each other. Then we have a radiant power or watt. In this mode, the emitted light will be measured in watts. In this unit, size and intensity of the lights do not relate to each other. Finally, we have watts per square meter per stadian. In this unit, obviously, size and intensity of the light relate to each other. Now let's use watts as our unit and set the multiplier to something like 10 watts. A multiplier basically controls the overall light and color intensity of the light. So if I increase it to something like 40 watts, you can see the light is a lot brighter. And if I set it to something like 2, it gets a lot darker. Now let's here set it to something like 10. Now remember, a normal 100 watt light bulb only emits about 3% of that power as visible light. So here when we use something like 10 watts as our multiplier, we are having the equivalent of about 3 100 watts light bulbs. Before going through the rest of these parameters, let's quickly talk about the relationship between the size of the light and its shadows. As the light gets larger, its shadow becomes diffuser, and as it gets smaller, the shadow is getting sharper. Now let's see it in our Vray RT. Let me first use a small size like 4 and 7. And as you can see, the shadow is very sharp. Now, let me increase the size to something like 24 and 39. And as you can see, the shadow is a lot less defined and basically it's diffuser. Now, remember, even though we have increased the size of our light, the scene didn't get brighter. That's because when the unit is set to watt, the size and intensity of the light do not relate to each other. Let me change the size of the light to 8 and 13. Then you have two modes to control the color of your lights. In the color mode, you simply select the color from here, and you can see the changes in the V-Ray RT as I'm kind of changing and using different colors. And in the temperature mode, the color of the light can be determined by using a Kelvin value. By default, it is set to 6500 and you get this white neutral color. A lower number, like let's say 3500, will give you a warmer, more reddish color, and a value higher than 6500, like for example 10,000, is going to result in a color, cooler, more bluish color. Now in this case, let's set this to something like 6500, which is the default value. Now next we have texture. If you enable this checkbox, you can specify a texture to be used as the color of your light instead of the above color options. Now before that, let me create a copy of this physical camera that we have. Press C and make the second camera your active camera. Position it in a way that enables you to see the light source itself and make sure that V-Ray RT is running. Now select the light again. Click on this None button to define a texture. You can select any map or texture, but there is a specific map in V-Ray that can help you resemble real-world softboxes, and no surprise, it's called V-Ray Softbox. So select V-Ray Softbox, press M to open up Material Editor, and let's drag this map to our active view. Double click on it to select it. If you come down, you can make the softbox to have a frame and a U vignetting. And as you can see, the softbox is quite visible on our light surface. And also it will be visible in our reflections. Now let's stop V-Ray RT and close these windows. Let me also untick this texture checkbox. Next we have this resolution option, which controls the texture resampling for the specified texture down here when MIS or multiple important sampling is enabled in our advanced option rollout. We will talk about MIS later. Let's continue with the rest of the options. Next we have our rectangle disc light rollout. As the name suggests, this rollout is only available when the light type is set to plane or disc. Let's get back to our main camera and make sure V-Ray RT is running. Using the directional option, you can make your light to be more focused and directional. As I increase the directional value towards 1, the light becomes more directional, and at 1 we have a fully directional light. Now we can use some fun textures to control our light. So for example, I can get back up to my general rollout, make sure I have a square light, maybe 13 and 13 or something like that. Enable the texture checkbox, click on the texture button, and from the general section select bitmap and select this window.jpg texture. Okay, and now if I use a multiplier like 5 or 6, you can see we have a pretty dramatic effect. Obviously, this is just a proof of concept and you can use more complex lighting and get better results. Now let me uncheck the texture checkbox again and change the half length to 8 and half width to 13 and set the multiplier back to 10. Then we have this preview dropdown, which helps to preview the effect of the directional parameter in the viewport. By default, it is set to never, so we cannot see any preview of the effect in the viewport. But if you change it to always, you can see a 90-degree light cone in the viewport. And as I decrease the directional value, the light cone becomes wider and basically less directional. When it is set to always, you can always see the preview whether the light is selected or not. You can change it to selected, and this way the preview is only visible when the light is selected. Okay, let's zero out the directional value and change the preview mode to never. Great, next we have the option rollouts. First, we have the exclude include window, which allows you to exclude or include specific objects in the illumination and shadow casting of the light. For example, I can double click on the floor object and exclude it from this light, and you can see the result in Vray RT. Let me double click on the floor again and remove it from the list. Then we have cast shadows, which controls whether the light casts shadows or not. Next we have double-sided. First, let me switch to my second camera and position it in a way so I can see the backside of my light. Right now, as you can see, the light only emits from only one side. That is because the double-sided checkbox is unticked. If I enable it, the light emits from both sides. This option only works with the light types that can have clear front and back side, so only plane and disc types. Let me disable this option and move my second camera in a way so I can see the light's front side. We have invisible, which controls whether the light source is visible or not. Right now, we can see the light source in the render, but if I enable it, now the light source is gone, but the light still affects the scene. We only can see the light source when seen through the camera or refraction. So if I had a refractive object like a glass, for example, in front of my light, I wouldn't be able to see the light through it when the invisible option is enabled. But the light source still can be seen in the reflections. Let me show you that quickly. In the render setting window and Vray RT tab, disable the override material functionality and get back to the main camera. Now, as I am enabling and disabling the invisible option, you can see it is still visible in the reflection and specular highlights. The visibility of the light in reflections is controlled by this option down here called effect reflection, which we will discuss it in a moment. Now, let me enable the override material in the render setting again. Also, let's get back to the second camera. Next, we have no decay. As you can see by default and also in real world, the surfaces that are closer to the light source are going to be brighter, and as the surfaces gets further away from the light source, they become darker. But if you have no decay enabled, the intensity and brightness of the light will not decay with distance. Let's disable it here. Next we have Skylight Portal and Simple. These are two very specific options, especially for interior lighting, and I'll be discussing them in a future lesson. Let me get back to the main camera. The next option is Store with Irradiance Map. Now, Irradiance Map is a method or algorithm to calculate GI. If I go to my render setting and change my target to production rendering mode and go to the GI tab, you can see one of the GI methods is Irradiance Map. When Store with Irradiance Map is enabled and Irradiance Map is being used as a GI method, Vray is going to calculate the effect of light in the irradiance map, and the result would be basically a faster render but with less defined shadows and details in the lighting. Now, if I open up my frame buffer, I have two renders, with and without the store with irradiance map option enabled. As you can see, when this option is enabled, the shadows are less defined in comparison with when this option is disabled. And also we have some problems seeing specular reflections in the version with store with irradiance map enabled. Let me disable this option. Now, the store with irradiance map option is useful when, for example, you have a secondary light, something, for example, like a fill light, and you don't need that much detail in the shadows that are casted by that particular secondary light. So in that case, you can enable a store with irradiance map for that particular light and see the render goes a bit faster, and you get basically the same result because the shadows aren't gonna be that defined anyway. Now let me disable this option here. Now let me close the frame buffer and open up the render setting. Change the target to active shade, and in the Vray RT tab, disable override material and heat render. Next we have effect diffuse, effect specular, and effect reflections. When effect diffuse is enabled, the light affects the diffuse portion of the material in the scene, and if I uncheck it, the light only affects speculars or highlights and reflections. Let's enable it again. The value here controls how much the light affects the diffuse contribution of the material. I can increase and decrease this value and you can see the effect. We have effect specular, which determines whether the light affects the specular contribution of the materials or not. And effect reflection, as we talked about it beforehand, controls whether the light is visible in the reflections or not. Next we have the sampling rollout. The first parameter is subdiv or subdivisions, which is grayed out by default. This parameter controls the quality of the light, how many sample basically Vray uses to calculate the effect of the light. In order to be able to basically tweak this parameter, you need to go to your render settings and change the target to production rendering mode. Go to the Vray tab, down to the global DMC rollout, and enable use local subdivs. Now, to see the effect of this subdiv parameter a bit better, let me go to my image sampler rollout and make sure the UI is set to expert mode so we can see all the parameters and options. Turn off divide shading subdivs and set the minimum shading rate to 1. Also in the bucket image sampler rollout and global DMC rollout, I'm going to change my noise threshold to 0.03. I'm altering these parameters simply to be able to present the subdiv parameters of the light a bit better. Okay. Now we're going to be discussing these parameters and these tabs and all these settings in their specific lessons, so don't worry about that right now. As I mentioned, I'm just trying to be able to present the subdiv parameters of the light a bit better. Great. Now let me show you 3 renders with subdiv parameter of the light set to 1, 8, and 64. This is the first render with subdiv set to 1. This one is set to 8. And the third one is set to 64. If I zoom in here using my scroll and compare the 1 and the 64 version, you can see clearly the version which has the higher subdiv is cleaner. Let me set the 1 version to A and 64 version to B and compare them. You can see clearly the B side is a lot cleaner. Let me get out of the comparison mode and set the subdiv of the light back to 8, and in the render setting you can set the noise thresholds to 0.01 and 0.01. Also, you can turn off use local subdivs, enable divide shading subdiv, and set the mean shading rate to 6. Change the target again to active shade, and in the Vray RT tab, enable Vray override material. And now you can basically start the render again. The next parameter is shadow bias. This parameter basically moves the shadow closer or farther away from the object. So if I increase this value, for example, to something like 2, you can clearly see the shadow is moving. And let me set this back to 0.02, which is the default value. Then we have cutoff, which is the threshold below which the effect of the light won't be taken into consideration. For example, if I set this value to something like 0.4, if at any point the effect of the light is less than 0.4, Vray wouldn't calculate that light anymore. And as you increase this value more and more, the cutoff point is getting closer and closer to the light source. Let me set this value back to 0.001. Okay, let me close all of these windows here. And next we have some very basic viewport options. Enable viewport shading lets you see the effect of the light in the viewport if you are in a mode like high quality. Now, if you want to change the wire color of the light in the viewport, you can use viewport wire color option. And you got the icon text, which lets you see the name of the light in the viewport. In our advanced option, we have use MIS or multiple importance sampling. If I want to loosely explain this option, is that it helps the secondary rays to find the light sources a bit easier in the scene and focus on them. I'll be going over this option when discussing mesh and dome light, but for the time being, I'm just gonna show you these two renders with and without MIS. In the first render, MIS is enabled, and in the second one, it is disabled. As you can see, when we disable it, some areas like these edges here are getting noisier and less clean. I'll be showing you a few more examples in the dome and mesh light lessons. Now, let me get back to my second camera and enable my active shade. Now, if I go to the general tab of my Vray light, in the type drop down, we have two other light types that I want to discuss in this lesson very quickly. First is disk light, and as I change the plane light to disk, you can see now the area light has a different shape, and also you get a parameter called radius to adjust the size of the disk, and I can try a radius maybe of, let's say, 2 and 8 and 16. And as you can see, as I'm increasing the radius, the shadow becomes more diffuse. Let's set it back to 8. Next we have sphere, and as I change it now, the light shape is a spherical shape. Maybe I can move my camera a bit so you can make sure it's a sphere. Also, here you have this kind of radius parameter to control the radius of the sphere, and as you notice, by changing the type to sphere, the rectangle disk rollout has disappeared. Let's change the light type to rectangle and get back to the main camera. Great. Basically, this lesson is finished, and you can skip the rest of this lesson and maybe come back to it when you finished watching all the tutorials in the lighting section. But if you want to continue, let's add a few more lights to our scene and make our lighting a bit more interesting. Now, let me select my main light in the top view, hold down Shift and create a copy. Let me adjust the position a bit. Now, this light is going to work as a fill light. I don't want to see those very dark shadows caused by the main light. Also, it's going to add some nice reflections on the clock. In the modify panel, let me increase its half width to maybe something like 45. Let's run the Vray RT and see what we got. As you can see, it's very bright. So I'm going to decrease its intensity to something like 2. And no, it's a lot better. If I select the second light and turn it on and off, you can see how the light helps us to get rid of those very dark, nasty shadows and also add a beautiful reflection on the clock. Now, the reflection on the glass part of the clock is not very interesting. You can see it's very sharp. So what I want to do is to use a very soft box as the texture for this light. If you remember, we created a very soft box texture early on in this lesson. So let's open up the material editor by pressing M and add that texture as an instance and make sure texture checkbox is enabled. Now, as you can see, the reflection of the light is much more interesting and realistic. Now, to make the lighting a bit more interesting, I would like to add a dome light. Now, obviously, we still haven't talked about that type of light, and you can skip this part and get back to it after we discuss dome light. But generally speaking, it's like a virtual sky. So let's just create a Vray dome light from the toolbar. Click on the Vray dome light icon and click wherever you want in the scene. Go to the Modify panel and click on the Texture button. This time we are going to use a Vray HDRI map. Let's load this HDRI. Now open up the Material Editor and drag the Vray HDRI to the active view. I just want to desaturate this map a bit, so let me right click in an empty space and add a color correction map from general category. Now hook it up with the Vray HDRI, select the color correction map and desaturate the input map by about 25. Now we can use this map as the texture of the dome light. So let's do that. As I don't want this light to affect my scene that much, I'm going to select the Vray HDRI map and set its override multiplier to something like 0.3. Great. Let's see the result in our active shade. Now let me turn this light on and off to see how it affects the overall lighting. Maybe it's a bit too bright, but I know I'm going to color correct it quickly, and this dome light is gonna add a lot to the final image. If I go to my second camera here, you can see the effect of this dome light quite a lot better. Great. Now let's get back to our first camera and stop the active shade. In the render setting window, change the target to production rendering mode, and in the render element tab, I'm going to add a render element called Vray denoiser. This element helps us to get rid of any high frequency noise in our render, which is great in this case. Click on the Add button and select Vray denoiser, and in the Common tab, change the resolution to something like 1200 and press render. Great. I'll be back when the render is finished. Now the render is finished and this is what we are going to get. Also, we have our Vray denoiser pass. I can take a look at it, and as you can see, it's quite cleaner compared to our RGB color pass. It's a bit washed out, and as you probably know, every raw 3D render needs to be color corrected. Thankfully, we have some color correction tools built in Vray Frame Buffer. What you need to do is to simply click on this icon that says Show Correction Controls. Let's enable our curve correction and add some contrast to the render. Then enable white balance. I'm trying to get a bit warmer render, so I'm going to cast out some of the bluish tone by increasing the temperature to something like 7600, and there you have it. And now you can save this image and open it up in Photoshop and apply your color corrections there too. Great. In this lesson we talked about Vray light in its plane, disk, and sphere shape. I will see you in the next lesson.